Welcome to Deep Engineering's YouTube channel, where we bring you real-world insights from the architects, engineers, and authors shaping modern software. Today, we are speaking with Ayodeji Ayodele, author of GitHub Foundations Certifications Guide, published by Packt. Ayodeji is a seasoned architect, DevOps evangelist, and agile coach with over 18 years of experience spanning financial services, tech, FMCG, manufacturing, and the public sector. He's worked with CIOs and engineering leaders across Asia, Oceania, and Africa to drive enterprise adoption of DevOps and agile practices, helping teams ship better software faster. Currently, as Senior Customer Success Architect at GitHub, Ayodeji helps large organizations integrate GitHub tools and workflows to meet real business outcomes across developer velocity, security, and collaboration at scale. And he's here with us today to talk not just about the book, but about how engineering teams can collaborate more effectively, how to use GitHub securely and at scale, and what GitHub Copilot tells us about the future of coding. So a very warm welcome to you, Ayodeji, and thank you for being here with us today.
Hi, thank you, Divya. That was quite a glowing introduction. Hello, everyone. You can call me Ayo.
Okay, great. So let's get started with your book first. What gap does your book, GitHub Foundations Certifications Guide, fill for today's developers, would you say?
Thanks, Divya. That's a great question. My book bridges the gap between knowing Git basics and truly mastering GitHub as a collaborative, secure, and a scalable platform. Many developers know how to commit and push code, right? But sometimes they struggle with collaboration, automation, and security. So I believe that the book helps with that. Secondly, the GitHub Foundation certification is a great benchmark, but in the past, there wasn't a practical hands-on guide to help people to prepare and apply those skills in real terms. Given the fact that the GitHub certifications in general are just barely 2 years old. So we don't have that many resources out there. I wanted to create a resource that's not just exam focused, but also helps developers to become confident contributors in any organization. So I wrote this book to help developers to go from I can use GitHub to I can lead with GitHub.
Wonderful, wonderful. And your book promises to take readers from fundamentals to advanced GitHub features, from effective collaboration and project management to secure workflows and even AI-powered coding with Copilot. Now, as you said, many developers use GitHub daily, but may not be leveraging features like issues, pull requests, etc. So how can even experienced developers benefit from this book that you've written? And what are some important GitHub best practices or features that even seasoned engineers often overlook?
Thank you, Divya. Yes, you're correct. Even seasoned engineers often miss out on GitHub's advanced features that can supercharge collaboration and code quality. For example, GitHub Copilot, our latest product, it's a massive game changer in the developer world, particularly if you're using it both within the IDE and on the GitHub.com platform. So GitHub Copilot is not just for the IDE. You can use and benefit from the great values that Copilot brings even on the GitHub.com platform. Not just that, it supports multiple IDEs, so up to like 6 different IDEs, which means you don't have to learn a new IDE for some of those other AI products in the software development space today. You can bring those models and still use the development environment that you already used today. So GitHub Copilot supports multiple models. So you can use all the GPT models. You can use the Cloud Sonnet models. There's also the Google Gemini models as well, all within GitHub Copilot. And then there are there is also the agentic capabilities that we now see the future of AI in software development going into, whereby you can have this huge backlog of issues, and then you can assign those issues to Copilot, and Copilot will spin up its own separate environment, triage that issue, and write the code that will fit the description to implement that issue. So that may be a feature request, or it may be fixing a bug and things like that. And going down the line, there's so many other things that are coming out in the next few months around helping to improve code quality as well. There is also a feature called the GitHub Advanced Security that helps people to manage vulnerabilities. And you can also bring in vulnerabilities that are reported by other security tools and even fix them within the same platform. So that's underused today. Then in terms of best practices, we've got the pull requests summaries in terms of improving the semantic for pull requests and titles. We have rule sets for protecting branches and for protecting workflows when you run them. And there's a huge number of different rules you can apply to improve governance and to improve CI/CD, automated checks, and leveraging issues for transparent communication and collaboration as well. And finally, mastering these tools elevates you from an individual contributor to, being a team enabler. So, GitHub isn't just a code repository. It's a platform for building better software together.
Right, right. And I think we're going to talk about that a bit more later on. So, as you said, mastering the skills that you sort of covered in your certification guide is not just a means for readers to use GitHub more efficiently, but it's also important for if they're looking for career growth and for leading teams in the future, isn't it? Right. Now let's talk a little bit about current industry trends and challenges. As we know, open source code now underpins almost everything. Now, given this ubiquity, what advice do you have for developers to harness open source effectively?
Thanks, Divya. Open source is the backbone of modern software. Contributing is the best way to learn. Contributing to these open source projects, it helps you to grow and also to give back to the community. In fact, virtually 50 to 60% of the software we have out there today were built or in open source or built on top of open source components and open source libraries. So open source is integral to how we build software in the world today. So I would say start small, such as helping to fix typos in some of the available public repositories today, and there are millions of those on GitHub. Improve documentation. So look at some of the documentation that you've got in these repositories and suggest improvements to them, to the content, and join the discussions. GitHub has got discussions, so you'd find discussions even for multiple repositories. Even GitHub as a platform, we also have a community called GitHub Community on discussions where people suggest improvements to GitHub as a platform itself. You can join those, add your voice to ongoing topics and conversations there. It's really good. And then you learn by doing. It's the agile way of doing things. It's one thing we believe strongly. So real world code, providing real feedback helps a lot. And of course, the balance is for you to also vet some of the dependencies, contribute to some of the trusted projects, the most popular ones that are out there. Open source is a two-way street. You give, you learn, you grow. So when you're giving back to the community, you're also gaining from the community as well. Yeah.
Yeah, that's a really nice way to put it. Now, but how can engineers get involved in open source projects on GitHub, but at the same time balance risks and rewards of depending on, community maintained code?
So rephrasing that question, so for me, I look at if you want to get involved, the first place to start will be github.com/explore. That's a place where you can see some of the repositories that are available. You would also see /trending, where you can see repositories that are trending at the moment that are getting more popular. Because there are times when you'll just see a repository that someone just recently published and will just shoot and skyrocket and become so popular within a short time because it's something everyone had been looking for. It may be a library, it may be a new design, templates, it may be scaffolding component and things like that. So it's a good place to start, and no judging, nothing there. You're just like everyone else. And GitHub platform is home to over 150 million developers. And it means that there are different people ranging different skill sets, different experience, and people having passion for different topics and different things. So you will always find a space for yourself to fit in. So that's one thing I would really, recommend. And in terms of risks, you may be wondering maybe, the code that contributes may not be up to standard, may not be up to standard practices and things like that. Or I don't want to shame myself. And, there is no shame. There are particular tools that help you to even build with a good standard. For example, if you're using GitHub Copilot, which is currently free for use, GitHub Copilot is free for open source projects. So you can use GitHub Copilot to help you suggest the code or improve the code itself. So even after you've written the code, you can ask Copilot and say, review this code for me, and it will review it to make sure it's up to certain standards. In addition, we have GitHub Advanced Security, and most of the security components are free for public projects and open source repositories. GitHub takes its leadership position as being the home where the world builds software, very seriously. And as part of that commitment, we provide these security tools and AI-powered tools to communities that build open source software free. So that's a place to really get started.
Yeah, that's some very good advice there. Now, moving more into sort of the enterprise context. Large organizations are increasingly applying open source collaboration practices internally. How can the principles of open source, such as open collaboration, transparency, fork and pull, be used within companies to improve teamwork and code reuse?
Thanks, Divya. Bringing open source practices inside the companies, which is InnerSource. That's what we call InnerSource, in short. It breaks down silos and accelerates innovation. So transparency, forking and pulling workflows, opening discussions, they drive better code and teamwork. So first and foremost, you want to be able to apply those principles. And there is a website dedicated just to inner sourcing if companies are looking to get started on that. I have a great colleague of mine, Yuki, is based in Tokyo. I think he's the president of the InnerSource Commons. So you can visit the InnerSource Commons website. There are a lot of very useful resources there to help you get started on inner sourcing. Then the challenge is there is usually resistance to change, and there is unclear ownership at times within enterprises. So you may be able to mitigate that when first you bring in that transparency to the teams, making sure people can contribute. You can provide certain rules and guidelines for contributing. So, for example, making sure you have what they call a contributing markdown file within the repository, providing the guidelines on how people can contribute. When you are very transparent on what this project is, what it can do, where we need help and things like that, other team members within the organization will be able to see exactly where they can help and then be able to suggest contributions to it. And there is also the GitHub discussions. People also create discussions within the enterprise. and collaborate and ask questions in such forum. So you can also implement a GitHub discussions forum internally. If you're looking for inspiration, the GitHub community, the one we use for GitHub itself, is a very good place to learn and see how the discussion forum works. So that's another very good thing. And leadership support is important as well. So you want to get the buy-in of the leadership within your enterprise and, celebrate contributions. So either you want to celebrate them at the community level or even get the leadership to help in the way you incentivize and celebrate those contributions. This might be through creating some badges or prizes to be won and things like that. So there are different ways where you can use that to encourage contributions and InnerSource. So InnerSource turns every developer into a potential innovator, right? Not just a code consumer.
Yeah, brilliant. But have you seen any challenges in adopting this inner source model? And what strategies do you feel can help overcome these challenges?
Yeah, thank you. So I mentioned earlier on resistance to change. People feel comfortable doing the same thing. And when something comes to, disrupt the status quo, people sometimes feel like, oh, we've seen this before, oh, well, I don't want anything to change. So a number of things there will be first to help on explaining what it's all about, making sure that it is judgment free, making sure the community, the internal community, supports everyone, providing clear guidelines on what can be done, and communicating. You can never over communicate. You want to ensure that you're keeping everyone in the loop on what you're doing as a program, when you want to get started, how you want to roll out this change, so that people feel comfortable with what's coming and they don't get surprised. And of course, I mentioned the leadership support to help you drive the change internally. You cannot underestimate leadership involvement within an enterprise on that. Yeah.
Got it. Now, moving on to automation and CI/CD in modern development. So, modern software teams automate extensively. How critical is this for developers to integrate CI/CD pipelines and automation into their workflow?
Yeah, thanks. So CI/CD is one of my favorite topics. CI/CD is critical. Automation is the heartbeat of modern DevOps, and CI/CD lets you to ship faster and safer. There are a number of things you can do continuously, and it can reduce the lead time for changes. When future requests come in, you want to shorten how quickly from when the feature request has come in to when you triage this feature and analyze what needs to be developed. Then you build. You want to be able to quickly scan this and validate that it's working, conduct regression tests and things like that to make sure what you're introducing is not going to break the rest of the application, all the way to deployment, right? So you want to be able to shorten that as much as possible. So it is very critical to be able to move faster. That's one. Secondly, it will help you to be able to standardize security practices and coding practices across board. For example, you can introduce pipelines. In GitHub, we have something called reusable workflows or organization workflows, where you can set automation that will be mandatory across all your repositories. Whenever you want to merge a pull request, that will run for every code changes. It can scan the code for vulnerabilities and secrets. It can also scan for linting and development standards and things like that before you can even deploy to production. So when all that is in place, you can rest that you know what you're deploying to production will be safe and secure. So it is very critical. Secondly, in this age of AI, a lot is moving faster. And if you're sticking with old traditional manual ways of making changes and deploying manually, you will likely be left behind. So when you put automation in place, it makes it easier and faster to be able to repeatedly deploy your code changes safely without causing any disruption to the system. And it also means that regardless of the person that is making those changes or deploying those changes to production, you will always get a consistent experience regardless because of the pipeline that you've put in place. So these are some of the DevOps practices and principles. So we've got things like infrastructure as code. We've got things like configuration as code, so that you are able to repeatedly do the same thing over and over again and in a shorter time. So these are some of the things that are, very important. So I would say, yeah, it's an integral part of software development.
So if we drill down a little bit more, what guidance would you give specifically for tools like GitHub Actions when it comes to streamlining testing integration, deployment, and to avoid pipeline overload?
Yeah, good question. I would say start with automated tests because that can immediately help you in terms of test coverage. When you add unit tests and you automate the testing of those test cases, you will not need to spend time between your dev or user acceptance testing and things like that. You will be able to shorten the time. Automated tests are usually a very good way to start. Then you can move on to deployments. And to avoid pipeline overload, there are some things you can do around conditions where you can specify rules and say, if this is a low risk or a low change or a low risk change, for example, you've categorized them based on your CI/CD. If it's a low risk, then continue the deployment to production so that the low hanging fruits can easily just go without much of a bottleneck. Then the very more complex ones, you can require a manual human being approval. So you can specify which human beings will approve your peer reviews to approve those ones. So you have minimal number of pull requests being reviewed every time. Then you can also implement what they call the code review agent. GitHub Copilot has got what we call a code review, such that for every pull request, you can assign that pull request to GitHub Copilot. So GitHub Copilot does the heavy lifting of reviewing the files that have changed and the code that has changed in advance, and will already provide its response and say, all right, this is good, this is what you need to improve within the pull request. What that means is that when the peer review is about to start and the human being comes in to review the code, you spend less time looking at the files that have changed. You spend less time reviewing the code because GitHub Copilot has already even reviewed the code itself and, being able to provide feedback. And not just that, GitHub Copilot can also suggest the fixes. And then you can automate and accept the suggested fix whilst within the pull request itself before you deploy. So these are things that can help to reduce the overload. And you don't need to automate every single thing. Automate what matters and keep it maintainable as much as you can. That's what I would advise. Automate the boring stuff. Focus on what makes your product unique.
Got it. Now, in your experience, what branching strategy works best for teams on GitHub?
Wow. I have a preference. So
Do share.
disclaimer, this is just an opinionated preference. For me, I prefer trunk-based development a lot because with the trunk-based development, you have one single branch, which is called a trunk. And every time you want to make changes, you create a copy of that in another branch. You make your changes, and when you're done, you create a pull request to merge back to that trunk. Once the review is successful and you merge, you can delete the branch that was originally created, which keeps the repository very clean, and you will have only one single branch every point in time. And you might ask, what if I need to go back in time and roll back a change or deploy a previous version at any point in time? Well, you have that in the history of the main branch. You can always create or cherry pick from that and create a branch to deploy. And when you're done again, you can always remove that branch. But that's not the only good branching strategy. There's so many other ones. There's the GitFlow, which is always, very good. The best branching strategy is the one that your team understands and they can execute consistently. What you don't want to have is everyone just doing their own thing. So you want to have a common understanding of, what kind of strategy you've chosen, and you stick to that and make sure everyone understands what it means and how to consistently execute that. So trunk-based development can boost agility for most teams. GitFlow is also great. GitFlow can work for, complex release cycles, and you want to have different release version numbers and you just want to lock them down on multiple deployments. So it's really good. So consistency and clarity matter. That's what I would say. Yeah.
Okay, so now we know what you prefer personally, but if I ask you objectively, if a team is aiming to improve deployment speed and collaboration, which would you recommend for them? Would it be trunk-based development or GitFlow?
Yeah, I would say trunk-based development because it's particularly if you practice agile or, in agile teams, it can really boost your speed because you know that you know how to you can quickly make quick changes, validate those, deploy them, remove them again, and you always have that clean trunk each time. So for teams that really want to move very fast or that practice agile methodologies, I would recommend the trunk-based development. And branching is not about the complexity, it's about the clarity and how you collaborate. So that is particularly important for teams. Yeah.
Okay, so are there any, if we talk about pros and cons about these two approaches, would you like to quickly summarize what trunk-based development is best suited for versus GitFlow?
Yeah. So if you're building software and you want to release features more often, say once every day, you want to release changes to the production environment, you know, you have sprint cycles, maybe 2 weeks iterations, very short sprint cycles. Trunk-based development will be, the best approach for that. If you know that you tend to have multiple release versions in production at any given time, rather than one single production latest version, if you are the kind of application or product where these customers or these consumers have this release, I have this release, a separate release version for different groups of your consumers, then GitFlow might be good for you so that you can always have those separate branches of the same code base and keep those and use those regularly. So, yeah, that's what I would say.
Right, right, brilliant. And now on to what I consider one of our big questions for this conversation, which is about securing the software supply chain. So, with software supply chain attacks on the rise, security is a huge concern. So, what steps should developers and teams take on platforms like GitHub to secure their code supply chain? For example, how important are measures like using Dependabot alerts, enabling two-factor authentication, etc., to prevent such attacks?
Thank you. First, security is everyone's job. Every role in the SDLC needs to consider security as very important. Not just the person that wears the security hat, the security architect. Every developer needs to factor in security into the code they build. So use the built-in tools you have on GitHub to protect your code at every stage. For example, at the development stage, there is something that is called push protection, GitHub push protection. It helps you to block secrets from leaking from your IDE while you're in the development and you're about to push that code to the remote origin, to the remote repository. GitHub will check if there are certain secrets in the code and block that commit from being pushed to the remote repository. So GitHub push protection can help at the development stage there, even before you get to CI/CD. Now, when you're about to merge, there are security configurations that you can use out of the box on GitHub that helps you to protect the code, for example, from accidental deletions of branches, from dependencies, from vulnerabilities. You can run scans on vulnerabilities out of the box with single click default setup for code scanning. For secret scanning, you can scan for code at rest or even code in flight within the pull request. So we have the branch rule sets that you can apply, multiple rules. There are also security configurations that you can apply to different sets of repositories. You can decide on whether you want linting to be activated, or even if you want to run an external API or external workflow, you can add them as conditions for the pull request. And for code at rest, I've also mentioned that you can have code scanning that can run at a predetermined frequency, whether weekly or monthly, and things like that, that will look at the entire repository and code base and all the repositories in the organization or in the enterprise. There is also the Dependabot, which looks at your dependencies and will recommend to you if you need to upgrade those dependencies and the versions for those dependencies, particularly if vulnerabilities have been identified in older dependencies. So it tends to help you to keep your dependencies up to date, and it gives you like automatic pull requests such that you can just merge the changes, the updated dependencies into your code. Then we have what we call build provenance. There is a standard we call this SLSA, SLSA. It's a build attestation standard, and there are different levels. GitHub currently supports build level 2, SLSA build level 2. So I'd recommend to make sure that your code is always on SLSA build level 2. You can implement build provenance within GitHub such that it can look at your code at the point of you want to deploy and look at the entire supply chain that is within your code base and all the dependencies and libraries, and provide an artifact or attestation that those dependencies are valid and okay from. And it's like a blockchain of your deployments to prove that nothing has come in between to make certain malicious changes to your code. And that build provenance will stay there on GitHub, or you can store that as an artifact in Artifactory or any other external package management tool that you may have. So those are some of the things you can do. In terms of securing access authentication, definitely you want a two-factor authentication. GitHub supports that, and you can use single sign-on with Okta or Azure AD or Azure Entra ID, and use that to manage access authentication as well as authorization. There are some things we call GitHub teams where you can use those teams to manage the roles. You can create custom roles that suit you and provide different permissions to different roles. So role-based access can be implemented on GitHub as well. And finally, signing the commits. You can specify settings to make sure that every commit you're making is signed and verified to add more confidence that the person changing code is the right person. Yeah.
Great. Some really solid advice there. Thank you for that. Now, shifting gears a little bit. Post-pandemic, many development teams are distributed. You perhaps work in a distributed team yourself. How do Git and GitHub enable effective asynchronous collaboration across different time zones and teams?
Yep. Like you rightly hinted, Yes, I work remotely. In fact, GitHub is a remote first company. So I work from home 5 days a week. I still go to the office every now and then, particularly when I need to have engagement. So I have a speaking session to speak to multiple developers in different enterprises and businesses. So I visit businesses and talk to developers and all that. But, remote work is great. And GitHub is built for asynchronous teamwork. It helps. You don't have to be in a meeting to be able to make changes on GitHub. And clear communication keeps, distributed teams to be in sync. So GitHub has so many features out of the box that allow you to collaborate asynchronously. We've got issues, for example, and right now today in a team where, other members of my team are in different countries, in Japan, in India, in Australia, for example. We have different product and engineering teams in different parts of the world, even people in the US. And GitHub Issues is that central place where we collaborate on a particular item. So GitHub Issues is very great at doing that. And then it also provides a timeline view where you're seeing each time everyone is making additional comments, and it both builds it in this chronological order. So you can see who has made different changes and different commits or comments to an issue, and issue labeling and things like that. So it helps pull requests as well. It comes out of the box. Pull requests is one very fantastic feature of GitHub, and I think GitHub was even the first to implement what we call a pull request. That has become a normal thing today in many source control management platforms. But pull requests is that collaborative space that allows you to review code together and make those recommendations for changes in the code. We also have wikis for building documentation that are great, GitHub pages, and discussions are really trackable. You can also use discussions for social collaboration. Yep, these are the different features I can say can aid that. And finally, there's GitHub projects, which helps you to build Kanban boards and the roadmap views and use that to collaborate on different projects.
Okay. And are there any like secret tips you'd like to share on like managing communication through GitHub issues, pull request discussion, wikis, everything else you talked about when we are talking about a remote team context?
Yeah, absolutely. And the fact that you work with different countries means you'll be working with people in different cultures, and it means there are different ways they interpret things. So one thing you want to always do is to make sure you are writing very clear, comments and actionable comments where people know exactly what you've done or what they need to do. So I would definitely recommend to write clearly, even though they're developers and we're geeks. Sometimes we just want to write in, shorthands and short comments and emojis. Emojis are not enough to just translate what you're doing, and regular check-ins as well, right? You want to have regular check-ins with your team. Maybe you have a sync maybe once in a week or once every fortnight and just meet. One of the agile principles I love is individuals and interactions over processes and tools, right? You know, leave just it's not just a matter of sticking to the process, grab a phone, you know, schedule an ad hoc meeting, quickly sync on 5-10 minutes and say, hey, this and this and that. I hope we're on the same page. So sometimes having regular check-ins can really help. And documentation, you don't want to keep code just there and leave it for everyone to go figure. You know, go put some very good documentation in there. And with GitHub Copilot now, you can ask GitHub Copilot to even assess the code base and build the documentation for you. So it's not, us developers, sometimes we find documentation a very boring task and we like to shy away from it. But now with AI, with GitHub Copilot, all that boring stuff, you can give it to AI to do it for you and build very concise documentation that is clear to understand for you. So making sure that every code base it has good documentation is also, a good thing. And great remote teams don't just share code, they also share context of the code they're changing, as well. Yeah.
Yeah, brilliant. And as you said, these are all best practices that are well established, but for some reason we have to keep reiterating them to people to follow. But what you said brings us very nicely into our next question, which was about culture and DevOps integration. Now, you have a background in DevOps and Agile coaching, like I mentioned at the beginning. We often hear that the right tools can drive cultural change. So, how do you see platforms like GitHub influencing team culture and process?
Yes, thank you, Divya. And I must say, GitHub is a fantastic tool for shaping team culture, particularly if you want to bring people from silos to becoming more collaborative. In fact, in the development world, we call GitHub social coding because it was GitHub that really brought that joy of writing code and working together and collaborating with people. Um, there's transparency when you're making changes, you're seeing the code changes that other people are making, you're making comments in the issue and the pull request that everyone can see, making sure there's transparency. It's really important. Providing feedback, when you're reviewing code, you can add inline comments and different things like that. And in a discussion forum, you can vote on a particular feature or a particular topic and things like that. And automation also drive, that continuous improvement. So when you put automation in place, it saves people time and they're able to use that time to invest back into, designing the solution or solving bigger problems. So having that automation also helps teams to really become more collaborative. So people feel this developer happiness when they use GitHub in a team setting. And GitHub thrives a lot on improving developer experience. So DevX is one very uh, core pillar of the way the platform is built and is shaped. Yeah.
Brilliant. And are there any common pitfalls teams should avoid when integrating GitHub into their DevOps workflows?
Pitfalls, um, over customization is how I'll put it. Sometimes platform engineering teams, in the name of trying to implement configuration as code and things like that, at times they just want to customize everything that needs to be done. And at times that can take away from that innovative and creative sides of people. And it can introduce more bottlenecks and administrative overhead. First, for you that you're maintaining the customization, and for the people that have to use that customization as well. If they end up taking more time to delivering a feature or deploying to production for your end users and consumers to use your application or software, then you want to be looking at that and to be reducing that. You need to find a balance between being able to customize and giving people that, that ease of doing things and creating software. So over customization, neglecting documentation. I've seen people create pull requests that have no description, nothing, empty pull requests. Well, with GitHub Copilot now, you also have pull request summaries, and Copilot can easily summarize the changes you've made in that pull request beautifully for you. So try not to neglect documentation. That's also one huge pitfall. And in agile teams, conducting retrospectives are very good. So try not to skip retrospectives. Retrospectives help you to look at what you've done very well, what you're not doing well, and to see what you need to change going forward. So it helps with continuous improvement. So skipping retrospectives, neglecting documentation, over customizing your platform can be pitfalls. And Culture eats tools for breakfast. But the right tools can change, what's on your menu.
Mhm. Oh, that's very well put. And I know you've sort of throughout this conversation, you mentioned the benefits of GitHub Copilot. And so let's talk specifically about Copilot and the future of coding. So, is AI assisted coding a boon to productivity? That's the debate now because AI pair programmers like GitHub Copilot have very quickly gained a lot of popularity. So, from your perspective, how is AI changing the day-to-day work of developers?
Very good question. In fact, as at 3 years ago, we didn't have anything like that. Let's say, I think maybe 4 years ago. And I've been in the industry now for about 20 years writing software, and I've never seen anything like this before. It fundamentally improves and changes how we write software today. And it's not just a buzzword. AI has come to stay. We've seen people reduce the time it takes to introduce new features to applications and also improve the quality of the code as well. So having higher test coverage and also having fewer vulnerabilities when they scan the code. On GitHub, we build GitHub even on the GitHub platform. We use the GitHub platform to build the GitHub people are using today. And GitHub Copilot is one of the contributors to our code base. In fact, GitHub Copilot is the number one contributor with the highest number of contributions per week, per month today on the GitHub platform, not an engineer. So that shows by how much even we also believe in the platform, in what AI has come to improve. The agentic capabilities that I've seen today, if I had them coming out of high school, I would achieve a lot of great things. So if you're not using AI today, you're likely playing a catch up. Because AI just helps you to move at a very faster rate and safely in a secure manner. So AI is now the pair programmer. You will now be seeing agents where you can then assign some complex or boring work to an agent within GitHub, the GitHub platform. So you can have multiple issues in your current iteration, and you can choose three, assign two to an agent, to Copilot agent, assign this to another Copilot agent, to another agent, and GitHub Copilot has different agents. And we will also be releasing so many new agents. Right now, there is the coding agent that helps you to write the code. There is also the review agent that will be reviewing the pull request, right? And there are so many other agents that are coming. So you will not have agents being your pair programmer or even your teammates. So in addition to a development team of 5, and if you have an agent of like 4 or 5 and running parallel jobs, imagine the kind of output you get out of that. So people that are using AI today are doubling and tripling their output and their throughput compared to those that don't have AI today. Yeah.
Now, so do you foresee AI assistants becoming a standard part of software development? I think the answer is yes. But
Yes.
yeah, so but how should developers, especially let's say junior engineers, take advantage of tools like Copilot, but at the same time continue to hone their own coding skills?
Yeah, that's a very important question. Um, GitHub Copilot not only helps advanced engineers that know what they're doing, GitHub Copilot can also help you as a junior developer, for example, to explain the code. So you can ask GitHub Copilot to get a better understanding of the code base. Let's say you inherited that from a senior developer or you just joined the team and you don't know, how the code is written. You can ask GitHub Copilot to even explain the code itself and to tell you different components of the code and what it thinks the code does. It can explain concepts for you, coding terminologies and development practices. It can also understand the internal standards within that business or that team and tell you, all right, these are the kind of libraries you use, these are the kind of components you use here. You can even ask questions such as, oh, how can I test run this application? Or I have been given a new task to make changes to the login page. Where do I get started? Just basic questions like that. GitHub Copilot can help you to go through that flow and do that. Secondly, GitHub Copilot helps with prototyping, right? So you're given a new work, an idea, there is a business requirement, but you're trying to, the ideation process is a complex task that many people underestimate that developers do today. Being able to translate ordinary business needs to what software will do, it can be a burdensome task just thinking about the creative process. And GitHub Copilot can also help you in terms of the ideation and the brainstorming and the prototyping as well. So these are very good areas a junior developer can get started. And when you're writing code, your code, GitHub Copilot can help in the code you're writing to review that code to make sure it follows certain coding practices, which means a junior developer can be working as if the person is an experienced senior developer with Copilot by their side. So you can solve problems with AI, not just write code.
Yes, yes. Now let's talk about caveats a little bit. Can Copilot negatively impact code quality? What is your take on this?
Ooh, that's a tricky one. Yes and no. Yes, in the sense that if you don't know what you're writing or what you're doing, and you just always use Copilot to build things, when something goes wrong, it will be hard for you to try to understand the code base to figure out how to fix it yourself. And if you find yourself in a situation where the AI tool you're very dependent on is not working for some reason, let's say you found yourself in a remote area, or you don't have internet access, or you're on a system where AI is not allowed in that company. Maybe you're building some, covert, highly secure environment software. How will you be able to cope? So you also want to make sure that you're understanding the code that has been written and you have the fundamental understanding of the language it's written in so that you will be able to triage some of those things. And in terms of whether AI in general can introduce bugs in the code, perhaps, depending on how you've prompted the Copilot to write the code. There are times when, if there is no good prompting, Copilot can build, or AI tools can build code in a different way because they have a wrong understanding of the context or what you've asked them to build. So prompting skills are very important. There's something called prompt engineering. It's a practice on its own. You can find out about that on how to write good prompts for AI tools for GitHub Copilot. Then there are times where you can create prompt files and instruction files for Copilot and say, I want you to behave in this particular way, and I want you to use this and these libraries. Because typically there are more than one ways of doing things, of solving problems, and GitHub Copilot may just choose the most popular way using the most popular components or libraries. But maybe you have a particular kind of library that is homegrown or that has been approved for use. You can create what we call Copilot instructions to instruct Copilot on which particular libraries to use. That way, you're not introducing bugs into the system. You're building it in a way that is accepted by the organization that you're running and working in. And whenever it introduces those bugs, there is an agent for reviewing the code that has been built. Whether the code was built by a human being or built by AI, there is the code review agent that you can use to review the entire code base itself and review it against best practices and even against your internal standard practices within an enterprise or a team. Yeah.
Okay. So, how do you feel teams can use AI coding assistance responsibly to ensure the generated code meets quality and security standards?
Good question. Not all AI coding tools are the same, and depending on which ones you use can determine, what kind of responsible use are available. For example, with GitHub Copilot being part of the Microsoft family, there is what Microsoft calls the responsible AI. Um, so there is an integral part of Copilot that looks internally for the responsible use of AI. First, looking at the kind of prompt you're sending, it will look at it and check it for ethical standards and sanitize it if you're sending in, you know, abusive language and things like that. Things that may be a problem. And when it's also giving you back the code, it looks at that code itself to be sure that, okay, is this a responsible use? Making sure there are no personally identifiable data and things like that in the record that it's sending back and things like that. So there's responsible use of AI from the system itself, depending on which AI system or product you're using. And of course, for the human being, I would say always make sure you're reviewing AI generated code. Make sure you're reviewing it properly, just as you would code that is contributed by any developer. Then use automated checks because the volume of what AI will be contributing to your code now will increase. It means it will be increasing your time to review on a regular basis. So you want to automate the review process, some part of the review process, making sure you're putting some automated checks in so that you reduce that burden of time on you while you will still be reviewing, making sure that a lot of the review work has been done in advance by automated checks to make the review process easier for you. So you want to treat Copilot as a collaborator, not a replacement. So you are not handing off everything to AI. You are working alongside AI, making sure you're reviewing what it's doing, which is why GitHub calls it the co-pilot, right? Not the pilot, so that someone is still in charge, driving what it does. Yeah.
Yeah. And continuing to talk about AI and its impact, the latest Stack Overflow developer survey shows an interesting paradox. Nearly 80% of devs are now using AI tools in some form, yet only about 3% highly trust the answers from AI. In fact, 75% of developers say they turn to a human colleague when they don't trust an AI's answer. So, how do you envision the collaboration between developers and AI tools going forward? For example, will coding become more about validating and refining solutions, perhaps?
Yeah, I think I'll be keen to see that report and see, when they say they don't trust AI, uh, also which of the AI tools they're using. It would be good to see a breakdown of that because I feel it may not be the same experience for every tool. With that said, this revolution itself, right? Oh, this is another time in history that we'll look back and see that huge changes occurred. This is another change. And there is, as expected, a bit of resistance when change is coming because people are just figuring it out. So they have not seen it before. They don't understand exactly everything it does and how it runs in the back end. And it's difficult to trust what you don't know how it runs or how it works. So I would encourage teams to really first understand which AI tools they've chosen and understand the architecture of that AI tool to know what's going on under the hood. And many of these AI tools also give flexibility to configurations and controls So you can tick off and on which particular things you want the AI to be able to do. And that way you can be able to control and decide the way the AI works and what it's allowed to see. For example, you can also exclude certain files and certain contents such that the AI tool will not look at those files. Maybe they are secret files and things like that. And it will never look at them, even in your code base. So this is, you want to be able to understand that architecture very well. And of course, knowledge sharing as well. Some people love it because they've used it very well and they've seen the in and out of it. And there are some people that are just testing the waters. So when people have a knowledge sharing sessions and things like that, it will help people to balance up and understand things better on the way some of these tools work. So yeah, I'll encourage knowledge sharing and critical thinking of these tools themselves, and just testing, looking at the design and the architecture and the documentation on how it runs.
Yeah, and that's some really good advice there. And yes, all tools are not the same. But so just to follow up to that, how can teams encourage knowledge sharing and mentorship so that junior devs still learn critical thinking instead of blindly accepting AI? Because that's a genuine risk that the community is facing at this time.
Yes, I would say use AI as a learning tool, not a crutch. Use the AI to understand and know things better. And you can also use AI to augment knowledge. At times, knowledge is scattered within an enterprise in different sources, and it's hard to have access or remember all those areas where knowledge is stored. Some may be in multiple repositories, multiple organizations. Some may even be in other platforms, SharePoint, Jira, ServiceNow, and things like that. Use AI to augment and consolidate this knowledge base so that people can have a richer source to to derive information from. So consolidating the knowledge base can really help. And of course, you want to continue to encourage people to host things like show and tell sessions, like meetups. They can really help to improve knowledge sharing, and you can also come and showcase what you've built, and people can look at it and ask questions, and with critical thinking, ask questions to maybe test your assumptions for the software you built, and that can help you to improve what you've done. But AI itself can help in the scaling of that, in bringing knowledge together, in building that. You can also capture notes and conversations and use AI to translate those and interpret those feature suggestions or improvement suggestions and interpret them back into the code, or document those comments and feedback into your repositories as issues or features that can be done later on down the line. So yeah, AI can do that for you, but humans have to ask the right questions. Yeah.
Yeah, that's a good point. And there's a lot of debate, and this is a debate that's been going on for more than 1 year now about whether AI will replace developers or simply augment them. And I think at this point, it's a bit pointless to go into that debate. But complex creative problem solving is still hard for some models, at least. And according to the Stack Overflow survey, roughly 40% of developers said that AI tools perform poorly on complex tasks. Having said that, since the survey was published, there have been quite a lot of developments and improvements. But given AI's current limitations, what uniquely human skills should developers focus on strengthening now to remain relevant, according to you?
Hmm. Um, Thank you. First and foremost, there was that comment about AI not being able to perform complex tasks. In the last 3 months, I've seen a major change.
Yeah.
The models have improved so dramatically, so drastically that you can you will be questioning and saying, you know what, this is going really magical. Um, so I've seen some AI models out there that can perform really complex tasks. So there are particular models that actually do more complex tasks and do a bit of critical thinking and think they take longer to provide a response. And then there are some models that take a shorter time and just give you on the fly. So there are different strengths to different models. Um, so yes, AI tools can carry out complex tasks, but AI can't replace creativity. AI cannot replace empathy. AI cannot replace problem solving. These are innate skills for the humans. I know I've seen some people trying to build bots out there that have emotions and empathy and things like that, but I don't think they can ever be like humans. So I don't think AI will replace human beings. So you want to focus on communication, on design thinking, and adaptability as well.
Right. And okay, what core competencies, if we talk about professional core competencies and not just, things that are innately human, will define a successful developer in the next 5 to 10 years? If I just ask you to sort of try your hand a little bit at like prophecy for the future, what do you think as tools like Copilot continue to evolve at an astronomical pace? What do you think will keep developers in good stead in the next decade at least?
Oh, yes. So the developer role is evolving as we know it. The developer role back in the days that and the job description will be changing because of AI, right? It's not that people won't need developers anymore. It's just that the developers will now need to have more sophisticated skills in a different way. So, one core competency you want to have as a developer is one, being able to use AI. Now, that is going to be a core competency. You want to be able to understand the AI tools that are available in your field and how to prompt and how to use them well. So, understanding and getting good prompt engineering skills will be very good. Problem solving skills will be very important because now that AI is doing some of the mundane tasks, you'll be focusing more on the business problems and trying to look at how you solve them. So, problem solving skills will be a very important will be important going forward. Then collaboration, right? The ability to work with both human beings and agents because you will now have them mixed up in the SDLC. So you will be interacting with other developers and other agents. So being able to know what task to give to an agent or what task to give to hand over or to the other agent or hand off to a human being and all that. So understanding collaboration with both human beings across multiple time zones and agents as well that don't have a human form, right? And of course, continuous learning. You learn every day, new things every day. Make sure that you are learning a new thing about your field, about your area every day. It helps a lot. Even the AI tools themselves are learning. The LLMs are built in such a way that they train themselves. Like they can train and even become better than they used to be. So why not human beings do the same? Continuous learning, making sure you keep yourself up to speed with the latest, improving on how to be better and things like that. So The best developers will harness AI. You have to have that skill to be able to use AI tools and not to be replaced by it. So the most valuable skill in tech isn't coding, it's learning.
Very, very, very well put. Very well put. And that brings us to the end of our conversation. Ayo, thank you so much for joining us and sharing your deep insights on GitHub, developer collaboration, and the evolving role of AI in software engineering. And to our viewers, thank you for watching. If you'd like to go further into the topics we covered, do check out Ayo's book, GitHub Foundations Certification Guide. It's a practical, hands-on resource for mastering Git and GitHub. Whether you're preparing for certification or just looking to sharpen your workflow, you'll find the book useful. And we provided the link for it in the description below. Until next time, this is Divya for Deep Engineering.